And we are now recording. So while I get set up, I did send a video yesterday. So if you didn't catch the announcement, I tried to send you an email. You should have gotten an email me and also from Canvas announcements that I had to cancel class yesterday, but it doesn't mean it's a holiday. I did make a video. Okay, so if you didn't get a chance to look at the video, go back and look at the video. So you were still responsible for it. Okay, so we're here. So I did some more problems in 5.5. So again, if you missed it, we didn't have class yesterday, but it doesn't mean there was nothing. I did make a mini video. It was only about 10 minutes long. So if you missed it, just go back and look at it later, okay? And that's all that's gonna happen today, and tomorrow I'll go back and do some more of 5.5. And then our last quiz will be tomorrow. Then Monday, Tuesday, I'll start reviewing for the final exam, but I'll also sneak in a little bit of review and, well, keep doing some 5.5, but I may go back and do my own 4.9, 5.1 that I think some of you may have had questions on, especially for the problems that I hadn't done yet, okay? And the other heads up I need to tell you is, I'm not sure, I may have, I'm gonna get you through the semester, don't worry. Okay, I may still have one or more days where I have to take off for stuff. Okay, but if that ever happens again, I'll make sure we're still going to have the test. I'll figure something out if needs be. You'll still have the final exam on this day. Okay, but there's still maybe one or more days where I won't be able to meet with you face to face at our normal 9, 10 to 10. But if that's the case, I'll just send a video out. Okay, so we're going to get through the semester somehow. Okay, but a heads up, I may have to skip one or more days coming up. But don't worry. Well, I'll make it so that we'll finish the course, okay? All right, so I did some problems from 5.5 last time. I'll do more of that type. I did introduce a new concept of substitution with a definite integral, where you have to change the limits of integration, and I'll be showing you some more of that today, okay? All right, so again, this is our remaining calendar. We have one last regular exam. You turn in all of this. I'll reserve Wednesday for questions and answers. Again, provided that it's a quote unquote regular day. Last regular exam is Thursday. So Friday, I'm not sure I'll get you back to tests on Friday. I'll have it by that weekend, but you'll at least get the solutions for it and we'll review the solutions. I'll have your exam over the weekend, hopefully. And final exam is 8:10 to 10:40, okay, on Monday. I do need to tell you, I'm guessing most of you won't take advantage of this, but I'm supposed to have office hours all that week. And so I can be reached by email Tuesday through Friday from 8 to 10 a.m. Okay, I'll try to put that in the Canvas announcements, one of these days. I mean, I doubt many of you would take advantage of that because the final exam would already be over, but I'm supposed to say it, so I said it, okay? All right, and let me check the chat. Anybody who just showed up, go ahead. Do we have class on 5:21? Yes, we do. And I think I'm caught up with everything there. Okay. All right, so moving right along. Okay, so I'm on 5.5, problem 59. Again, we're mixing up definite and indefinite integrals intentionally. Okay, and for those of you who caught the video last time, I got up to 55. Okay, so 59, but I'm jumping back and forth. The reason why I'm jumping back and forth is I want to include definite and indefinite integrals in our mixture so you can recognize the difference between them. Okay, so integral from 1 to 2 of e to the 1 over x divided by x squared dx. Okay, this might be a little bit hard to see, but think of this as x to the -1, right? This is essentially x to the -2. And the derivative of x to the -1 is almost x to the -2. So that leads me to believe that this should be u. So u equals 1 over x, which is x to the -1. Du is negative x to the -2 dx, which is -1 over x squared dx. Okay, so I have 1 over x squared dx. You say, where's the 1? You're going to always pretend there's a 1. So I need to introduce a -1. So -1 inside and also outside. That way I'm multiplying the entire expression by 1. And change the limits of integration. I introduced this yesterday. Okay, so when x goes from 1 to 2, what happens to u? Okay, why plug in? So if x is 1, u is 1. If I plug in x is 2, u is 1/2. and it has to be in that order. So you can't go by smallest to largest. You just got to go by order. If I plug in 1, I get 1. If I plug in 2, I get a half. So 1 has to be in the bottom. 1 half has to be on the top. There's a negative 1 on top. This now becomes e to the u, and all this stuff, negative 1 over x squared dx, that's my du. Okay. So this is backwards, and there's a negative, but there's a very easy remedy for that, right? That we've seen before. Change to a positive, switch these around, and it's the way that we like it. Smaller number in the bottom, bigger number on the top. Okay, and this tends to happen quite a bit. Okay, so a lot of times when you do a u substitution, you notice after substituting, hey, the smaller numbers on the bottom, smaller numbers on the top, bigger numbers on the bottom, and there's a negative. Very easy remedy. Just take off the negative and switch these two around. Now we're good. So notice when you substitute with a definite integral, no need to go back to the original variable. Okay, so that's u, that's du. These limits are with u. I don't have to go back to x. Okay, so integral of e to the u is e to the u. Plug in 1, you have e. Plug in a half, e to the 1/2. So e minus radical e. Okay, 67 is actually very different. It's kind of like problem 47. I'll show you 47 later. So when we go back and do 47, it's similar to 67. Integral of x, radical x minus 1 dx. Okay, temporarily ignore the reds, as you know. There's real no substitution I can do for this. I mean, if I let u equal x minus 1, the derivative is 1, so it doesn't really help. Okay, all that's going to happen here is this is nice, this is not as nice. By making use of the substitution, I'm going to make this nice. This will not be as nice, but I at least have a nice square root, so to speak, and you'll see what I mean by that. Okay, so this is nicer than this. I'm trying to force this to be nicer than this. Okay, so u equals x plus 1, which means du is dx. So I can immediately change dx to du. And now I'm going to solve for x. X is equal to u plus 1, right? Just add 1 to both sides. Okay. And I change my variables. When x is 1, put a 1 here, u is 0. X is 2, put a 2 here, u is 1. So my new integral is going to be from 0 to 1. It's a definite integral. And now what's x? U plus 1. Radical x minus 1, radical u, and dx is the same as du. Okay. So what happened from here to here? This was nicer than this. All that happens is the radical became nice. This became not as nice, but it's now something I can deal with. This is u plus 1 times u to the half. Okay, so u to the 1 times u to the half, u to the 3/2. 1 times u to the half, u to the half. Okay, so now that should be pretty straightforward. Okay, u to the 5/2 divided by 5/2 plus u to the 3/2 divided by 3/2 from 0 to 1. Plug in 1, you have 2/5 plus 2/3. 1 raised to anything is 1. Plug in 0, 0 to the 5/2 is 0, that's 0. Okay, so it's just 2/5 plus 2/3. Common denominator is 15. Multiplied by 3 over 3, 5 over 5, 6 plus 10, 16 over 15. So that's my final answer for that one. Okay, so I'll go back and do my focus thing on 59 and 67. Right. Okay, next problem is a little bit different. It's 45. I'm going to show you 45. It's an indefinite integral. Remember, indefinite integrals, answer is going to be blah, blah, blah plus c. 1 plus x over 1 plus x squared. Okay, there's no good way to substitute here because the derivative of the bottom is 2x, which would be good if I only had an x, but not when there's a 1 there. Simple solution, just break it up into 2. Break it up into 1 over 1 plus x squared plus x over 1 plus x squared. And in your algebra class, you probably didn't do this very much. You went from here to here a lot, Okay, think back to your algebra 1, right? If we said, how do you combine these? Then you would say, oh, common denominator, just add the top. Okay. Well, you're allowed to go backwards. I could start off with that and break it into this. And then I split this into 2 separate integrals. Okay, so here's where it's almost like you have to take time out, figure this out, and then put them all together. So the original integral, I'm going to say is I1 plus I2. So when I get the answer to I1, get the answer to I2, put them together for my I. Okay, so I1 is the integral from 1 over 1 plus x squared dx. That's simply inverse tangent of x plus C1. And why C1? Because there's going to be a C1 and a C2. Technically, I can't just call this C and I can't call this C because that implies the C's are the same within the same problem. I'm going to call this C1. I'm going to call the other one a C2. But in the final answer, you're going to get a C1 and a C2. That can be combined into just a C. So that's my inverse tangent. Okay, now let's look at I2, which I can do by substitution. Okay, so I2 is this. What's the derivative of the bottom? 2x. So put a 2 inside, half outside. So u equals 1 plus x squared, du equals 2x dx. So my integral becomes 1/2 2x dx is now du divided by u. Okay, you can pretend there's a 1 there. 1 over u, you should say, oh yeah, that's my natural log. Okay, so 1/2 ln absolute value of u plus C2. Again, you shouldn't just put C, because that would imply these 2 C's have to be the same. So here, temporarily, you say C1, temporarily, you say C2, but in the final answer, when I put them all together, it would just be C. Change u back. What was u? 1 plus x squared. Okay, and now here's something new. How do I go from here to here? Absolute value means if it's negative, make it positive. But take a look at this expression, 1 plus x squared. Can that ever be negative? No, impossible to be negative, right? It's got to be positive. So if an expression has no chance of being negative, you drop the bars, okay? And that's considered proper. You should do that. Okay, so back to regular parentheses, 1/2 ln 1 plus x squared plus C2. Right, and finally, I put it all together. So since I1 plus I2 equals I, my original integral of the I is inverse tangent of x plus what I got here, 1/2 natural log 1 plus x squared plus C1 plus C2, but now plus C1 plus C2 can be combined to just regular C. Okay, so that was a little bit different problem. Okay, it was so different, I took up an entire page for that. So I'll do the focus thing on this, and then I'm done with that page before I go on to more problems. Okay. All right, so that's it for that. Let me quickly check the chat. Anything else in the chat? No, I think we're good. Okay. Okay, 5.547 is sort of like the other one that I did involving the radical, but this is a little bit harder. Okay, so the original was x times 2x plus 5 to the 8th power dx. So same thing, this is harder, this is easier. And I can't really do any substitution. If I said u equals 2x plus 5, the derivative is 2, but I wouldn't have a way to get rid of this. Okay. Well, believe it or not, we're going to do it anyway. Okay. Now, there's no way you're going to multiply that all out. You don't want to go 2x plus 5 to the 8th power. Okay. Okay, this is nice. This is not nice. It's almost like anything that you have to raise to a power. Let's make that one the nice one. So I'm going to transform this problem so that this is not nice, but at least it's to the first power. And this is really nice. Okay, so in other words, let u equal 2x plus 5. du is 2 dx. That means I need a 2 inside, half outside. Okay. And I need to solve for x. Well, that's easy, simple algebra. If u equals 2x plus 5, subtract 5 divided by 2. X is u minus 5 divided by 2. And I trust you can all do that. Okay. Now, if you were in my Algebra 1 class, I'd go slower, but you all know how to solve for x there, right? Subtract 5 divided by 2. I believe I can go over that quickly. All right, so here's how we substitute. The next step, this is going to be u. This is du. I got a half outside. That x is going to become all of this. That's going to be u. Okay, so this was nice. This is not nice. I'm transforming the problem so that this becomes nice and this is not nice. That's what I prefer. So here we go. 1/2 x u minus 5 over 2. 2x plus 5 is u to the 8th du. Okay, so look at what happened. Nice, not as nice. Not as nice, nice. Okay, and by making it like this, now that the thing to the 8th power is just u, I can combine it, right? So what do? Take the 2 out. So 1/2 times 1/2 is 1/4. And then I just distribute right here. That's easy. U times u to the 8th is u to the 9th minus 5u to the 8th du. And then I'm pretty much home free. Okay, so 1/4 u to the 10 over 10 minus 5u to the 9th over 9 plus c. Indefinite integral means substitute back for u. You might recall for the definite integrals, we had no need to substitute back, right? We didn't have to. So definite integrals, you change the limits, right? And then you don't have to substitute back. Indefinite integrals, you don't have a choice. So change u back to what it was. What was it? 2x plus 5, and that'll be it. Okay, and I distributed. So 1 over 4 times 10, 1 over 40, 2x plus 5 to the 10th, minus 1 times 5 is 5, 4 times 9 is 36, 5 over 36, u to the 9th is 2x plus 5 to the 9th plus c. So there's my final answer. Okay. All right, let's see, check the chat. Yeah, anybody who joined late for attendance, please put your name in the chat. All right, 35, another indefinite integral. Then I'm gonna do a definite integral. You say, why are you bouncing back and forth between definite and indefinite? I want you to recognize that, right? So on the exam, you can say, do I do definite or indefinite? You look for whether there are numbers here, right? So for 35, no numbers. So what does the final answer look like? It looks like blah, blah, blah plus c. Definite integrals, there are definite numbers. What does the final answer look like? A real number. Okay. All right, so 35, radical cotangent cosecant squared dx. Okay, it's pretty much tailor-made. What's the derivative of the cotangent? Negative cosecant squared, right? And by the way, if you want to put that in your cheat sheet again, you may. So let u equal cotangent of x. Du is negative cosecant squared x dx. There wasn't any negative in the original, so put -1 inside, -1 outside, then we're ready. So now when I substitute, I'll have a negative radical u, and then -1 times cosecant squared x dx, negative, which means -1, cosecant squared x dx, that's my du. Okay, and then I'm integrating radical u. By the way, side note, don't let u equal the square root of cotangent x. That's more convoluted than you need it to be. If you include the square root, then you have to do the chain rule. You'd have blah, blah, blah to the half. The derivative is going to be more clumsy. 1/2, blah, blah, blah to the -1/2 times the derivative of the inside. No, just leave it as cotangent x. You will have a radical u, but that's easy to integrate. Okay, so negative u to the 1/2 du. Integrate. Integral of u to the 1/2 is u to the 3/2 divided by 3/2 times 2/3 plus a constant. and then just change u back to what it was. U was cotangent of x. So final answer, negative 2/3 cotangent x to the 3/2 plus a constant. Okay, 69, it's a definite integral. How do I know? There are numbers here. Looks like weird numbers, but there's a reason why they gave these weird numbers. It actually comes out nice. E to the 4th dx over x radical ln x. Okay. As usual, when you start the problem, ignore any red. The original problem didn't have any red. But do you see a function and its derivative, which is the whole idea behind substitution, right? There's an ln x, and what's the derivative of ln x? 1 over x. And you say, I don't see the 1. Well, you can always sneak in a 1. I mean, dx is like 1 dx, so I sneak in a 1. So u equals natural log of x, du is 1 over x dx. So perfect. That's going to be, instead of radical ln x, it's going to be radical u. And 1 over x dx is going to be my du. And this is a definite integral. I change the limits. So x is going to go from e to e to the 4th. U is going to go from something to something, which probably isn't the same. All right, so I plug in e. Ln of e is 1. Okay. A nice way to remember it, if you have trouble remembering that, is remember ln e, that's like e to the 1. Then you say, oh yeah, ln e cancel out, so I have 1. If I plug in e to the 4th, u is ln e to the 4th, ln and e cancel, so 4. So that's nice. My new integral is going to go from 1 to 4. So e to e to the 4th will change over to 1 to 4 du over radical u. So here we go. Integral from 1 to 4 du over radical u. The 1 and the 4 are for u. So notice the original had x, bunch of x's, dx, and the limits were x. The new problem has u, du, and the limits are even u. No need to switch back to the original x. We've burned that bridge. Just forget about it. Just solve this. Okay, radical u in the bottom means u to the negative 1/2 du. So power rule, add 1 to negative 1/2, you have u to the 1/2. U to the 1/2 divided by 1/2 means times 2 from 1 to 4. U to the 1/2 means square root, so 2 radical u from 1 to 4. You're allowed to factor out the 2. Plug in 4, square root of 4, minus, plug in 1, square root of 1. So 2 times 2 minus 1, 2 minus 1 is 1. Final answer is 2. There we go. Okay, again, what are we getting? A signed area. Well, in this case, let's see, e is positive, e to the 4th is positive. Everything here is positive. So whatever this graph looks like, weird graph, you're going from e to e to the 4th. The exact area under the curve, believe it or not, is 2 units. Even though this graph looks bad, these limits are bad, we have exactly 2 units, not 1.999, not 2.001, exactly 2. Okay. Very powerful theorem, as you can see. Okay, 71, well, it's the last major one I was going to do. I'm going to do more, but I'm going to start reviewing for the test even now. Okay, so integral from 0 to 1, e to the z plus 1 over e to the z plus z dz. I know it's kind of weird to have z, but a letter is a letter. We're used to x dx, but you can have y dy, z dz, theta d theta. It's the same thing. Okay. All right, so look at these two. The derivative of which one is which? In other words, is the derivative of the bottom the top, or the derivative of the top the bottom? The derivative of the bottom is the top, right? E to the z plus z. The derivative is e to the z plus 1. That tells me this should be u. In case you're saying, how do you know which one's the substitute? Okay, the derivative of this is this. So let u be e to the z plus z. Du is e to the z plus 1 dz. Perfect. I don't have to multiply by anything. I do have to change the limits. So z is going from 0 to 1. So plug in z is 0, put a 0 there, 0 there. You get 1 plus 0, which is 1. Plug in z equals 1, e plus 1. Okay. So when z travels from 0 to 1, u travels from 1 to e plus 1 because of this relationship between z and u. So my new integral is e to the z plus 1 dz, that's my du, over e to the z plus z is u, and I'm integrating from 1 to e plus 1. Okay, these are for u. I got u, du, the limits are u. I don't have to go back to the original z. So I'll be finished. All right, so ln absolute value of u from 1 to e plus 1. Plug in e plus 1. The absolute value of e plus 1 is e plus 1. E is like 2.7 plus 1, so it's about 3.7. So the absolute value is e plus 1. Minus natural log of 1. Natural log of 1 is 0. So ln parentheses e plus 1. And there we go. Okay, that's it for that. I did get some requests to start reviewing some problems, even though the test isn't until next Thursday. Okay, I'm going to start putting in some mini reviews, and I'll do a little bit of that tomorrow, but I'm going to give most of your time tomorrow for our last quiz that we're going to have. Okay, and then, so for now, Monday, I'll review maybe the first and second exams and sneak in some review for the test. Tuesday, I'll review exams 3 and 4 and maybe sneak in some more. And then Wednesday, I'm just going to let you have the entire time, but I'm going to start doing a little bit of review even now. Okay. Let me check. Okay, what's the funny looking S? Okay, the funny looking S is the integral sign or integral symbol. Okay, so integral. Okay, so integral. So I'm not really testing you on that, but so. Integral sign. Integral sign. Okay, and yeah, the side note, I guess the joke for Mr. Stewart is that's the symbol he decided to use for the cover of the book. It's got a violin here. He plays the violin, but you violin players or string players see that funny looking S, right? So he thought, oh, that kind of looks like the integral symbol. So he decided to put that violin in his book cover, I suppose. Okay, so I'm going way back to 5.1, number 5. Okay, because somebody asked for it. Let's see, 5.1, number 5. I'll still do some more problems in 5.5 also. But I already had some prior requests. 5.1, number 5. Estimate the area under the graph of f of x equals 1 plus x squared from x equals -1 to 2 using 3 rectangles and right endpoints. Okay, so I'll just do the right endpoints one. And again, most likely on the exam, I won't make you do all 3, left endpoints, right endpoints, and midpoints. I'll just have you probably do 1. All right, so here's a quickie graph of that. So chop it into 3 pieces. From -1 to 2 is 3. So if I chop it into 3 pieces, delta x is 1. Okay, so here we are. -1 to 0, 0 to 1, 1 to 2. Okay, take the right endpoint. Here's the graph. Okay, so go straight up, draw a rectangle, go straight up, draw a rectangle, go straight up, draw a rectangle. Notice sometimes the rectangle is too big, sometimes the rectangle is too small. Depends what part of the graph you are, right? Here the graph is decreasing, so it looks like the area is too small, I lost all this. But over here, the rectangle is too big, I got this extra area. And this looks like it's also too much. All right, so R3, the Riemann sum, base times height, base times height, base times height. All the bases are the same, delta x, which is 1. I like multiplying by 1. And then the function value at the right endpoints, f of 0, f of 1, f of 2. Okay, so plug in 0, 1 plus 0 is 1. Plug in 1, 1 plus 1 is 2. Plug in 2, supposedly it's 5. Plug in 2, 2 squared is 4, plus 1 is 5. So our approximation is 8. Right? Okay, going back to fundamental theorem of calculus part 1, 5.361. Okay, I know we talked about these problems before, but capital F of x is the integral from x to x squared, e to the t squared dt. How do you take the derivative? Okay, so remember, if you got a constant and a constant, break it up into 2, go from x to 0, and then go from 0 to x squared. And then in order for me to differentiate, okay, the rules of the game for FTC1, fundamental theorem of calculus part 1, is the bottom needs to be a constant and the top needs to be a variable. So this is good to go. This one is backwards. So you switch to 0 and the x and put a negative in front. And these kind of problems are always the same. I mean, if you just want to mechanically say it's always going to be that way. If you have two variables, break it into x to 0, 0 to x squared, leave that one alone, turn this around. It's always going to be that way. So now f prime of x, remember to put the negative here. Then for this one, all you got to do is put the x there. So negative e to the x squared. This one, all you got to do is put x squared there. So e to the x squared squared, e to the x to the fourth, times the derivative x to the second, which is 2x. So final answer is negative e to the x squared plus 2x e to the x to the fourth. Okay, 37, which I think we also did, but I got a request for that. Okay, just distinguish between x to the e and e to the x. Okay. This is the power rule. This is not the power rule. So this one is x to the e plus 1 over e plus 1. But watch out. This one, do not go e to the x plus 1 over x plus 1. The integral of e to the x is just e to the x. Just leave it alone. Okay, definite integral. So 0 to 1. Plug in 1. 1 raised to anything is 1. So 1 over e plus 1 plus e to the 1, which is e. And then you subtract whatever you get when you plug in 0. So 0 to that is 0. 0 divided by that is 0. Plus e to the 0, which is 1. So final answer, 1 over e plus 1 plus e minus 1. And just leave it like that. Okay, no decimal approximations. You know, I guess if you want to punch it in a calculator, you can. It's not a calculator class, of course. Okay, so let's say if you give me this and a decimal approximation, that's fine. But I insist that you at least give me the exact answer. This is considered the exact answer. Okay, and I'm done with this page. So let me do the focusing thing again. All that. Again, a good reminder. So even though we didn't meet yesterday, I did make a video. So if you didn't catch that, okay, I mean, sometimes students would say, oh, we don't have class, I'm finished. Well, not in my case, I still made a video. So go back and watch yesterday's video. It's not that long. I think it was only 10, forgot 10, 15 minutes, something like that. It's definitely not an hour. So I condensed it. So that's all that. Okay, way back to 4.961. I'll show you that one. Page 357. Find the position of the particle. They give you the acceleration is 2t plus 1, s of 0 is 3, v of 0 is negative 2. Okay, so how do you do something like that? So remember, acceleration is at the second derivative level. Velocity is at the first derivative level. And s is the function level, right? So it was really the same as all these problems on page 356. You know how they give you the second derivative, right? Like 27, double prime, integrate, you get prime, integrate again, you get the function. We were going backwards from everything we did the rest of the semester, right? Most of the rest of the semester, here's f. Take the derivative, f prime. Take a second derivative, f double prime. Now we're going backwards. Start with the double prime. Integrate, you're back up to f prime. Then integrate again, you're back at f. Same thing in physics. So just realize, of course, acceleration is at the second derivative level. Velocity is at the first derivative level, and s is the original function. Okay, so the velocity is the integral of 2t plus 1 dt. And I know that sounds weird because before section 4.9, for all the rest of the course, we said, hey, to get the velocity, we take the derivative of s. That's right, but you didn't start there. You started at the acceleration, which is at the second derivative level. So if I integrate, I'm up at the first derivative level, even though I didn't take a derivative, I'm taking antiderivative. Okay, so v of t is the integral of 2t is t squared. Okay, you should start getting somewhat proficient at this, that 2t. Okay, if you want to go slow, you would say 2t squared over 2, and then the 2's cancel out and say t squared. Integral of 1 dt is t plus c1. Okay, double check. What's the derivative of this? 2t plus 1 plus 0. So it works. Now they tell me v of 0 is -2. That means -2 is the answer when I plug in 0. So -2 is equal to put a 0 there, 0. Put a 0 there, 0. So -2 is 0 plus c1. That means c1 is -2. Actually, this should be equal. Probably equal. Okay, so put -2 back in here. So my velocity function is t squared plus t minus 2. All right, so integrate again to find s. So s of t is the integral of this guy. So t squared plus t minus 2 dt. So it's t cubed over 3, or 1/3 t. Okay, integral of t is t squared over 2, or 1/2 t squared, minus 2t plus c2. And now how do I find c2? I'm given that s of 0 is 3, which means if I plug in 0, the answer is 3. So plug in 0. Plugging 0 is easy in this case, right? 0, 0, 0. 3 equals 0 plus 0 minus 0 plus c2. That means c2 is 3. So just put that right back in here, and there's my answer. So s of t is 1/3 t cubed plus 1/2 t squared minus 2t plus 3. Okay, and I'll do my focus thing again. And that's it for that one. Okay, then let's see, go back to a couple more from 5.5. Let's see. So I'll be done after showing you a couple more. 51. E to the cosine x sine x dx. Okay, definite or indefinite integral? Indefinite, so my answer is going to have a plus c. Okay, derivative of sine is cosine, derivative of cosine is negative sine, but I don't really have cosine, I have e to the cosine. So that tells me to let u be cosine x. So if you let u equal sine x du is cosine x dx, but I don't really have cosine. Cosine is floating up here. So let u be cosine x. Derivative of cosine x is negative sine x dx. There's no negative, simply just put a -1 inside and a -1 outside. All right, so that leaves the integral as negative integral of e to the u du. That's u. -1 sine x dx is my du. So I have negative e to the u plus c. And simply change u back to what it was. What was it? Cosine. So final answer, negative e to the cosine x plus c. double check. What's the derivative of this thing? The derivative of this, okay, the derivative of a constant is 0. That's always easy. The derivative of this would be the same thing, right? Negative e to cosine x. Then by the chain root times the derivative of the cosine, which is negative sine. The negative would cancel that negative, and I have left over e to the cosine x, sine x. Perfect. It works. Okay, and the last one I had was 63. So let's see, so I'll probably finish a few minutes early. So it'll take me maybe 2 minutes to finish 63. Then I'm finished unless anybody else has a question. Okay, and then a reminder, so tomorrow I might sneak in a little bit of a mini review, but I'll give you most of the time for the quiz. Okay, next week, I was planning to review the first and second tests Monday, third and fourth tests on Tuesday, and then review for our last regular test Thursday, and then Friday review for the exam 5, and then that's what you use to study for the final exam. Again, I'm not promising I can get you back your test that fast on Friday, but I'll get it to you over the weekend. But at least you would have the solutions hopefully by this day over here, and then you should be all set for that. Okay. Okay, so the original was integral from 0 to 13 of the cube root of 1 plus 2x squared on the bottom. Okay, so let u be 1 plus 2x. du equals 2 dx. Okay, so I need to put 2 here and a 1/2 here. Change the limits. Okay, x is going from 0 to 13. What happens to u? So I plug in. If x is 0, u is 1 plus 0 is 1. X is 13. 2 times 13 is 26 plus 1 is 27. So when x goes from 0 to 13, u goes from 1 to 27. So my new integral has a half in front, 1 to 27. 2 dx is my du. And then cube root of u squared. Cube root of u squared means u to the 2/3. What you're going to bring upstairs is u to the negative 2/3. All right. My new problem is u du. These limits are even in u. I don't have to go back to the original x. All right, so 1/2 power root. What's 1 more than negative 2/3? 1/3. So u to the 1/3 divided by 1/3 times 3 from 1 to 27. This is 3 over 2. U to the 1/3 means cube root. Okay, very nice. Both of these are perfect cubes, so it comes out. So 3 over 2, plug in 27, minus plug in 1. What's the cube root of 27? 3. What's the cube root of 1? 1. So 3/2 of 3 minus 1. 3/2 is 2. Final answer is 3. So that is that. Okay, so let me do my focus thing, and then I'm just about done. We're almost out of time. So if anybody has maybe a quick question, I'll take it, but if not, we'll be done. Tomorrow, I'll do very little, and then go straight to the quiz afterwards. And there's that. Okay, so that's it. Anybody with a question? Let me check the chat. What was the quiz going to be about? Okay, so the quiz is going to be on integration. You have some definite integrals, for maybe indefinite integrals, and maybe substitution also. Okay, so all of those are fair game for the quiz tomorrow. Okay, so just integration, essentially. Okay, any other questions? Otherwise, we'll call it a day. Let me check the chat. Anybody who joined late, please put your name in the chat now so I can get you. All right, so that'll be it for today, folks. Okay, everybody have a good day, and we'll see everybody tomorrow. Okay, bye, everyone.